It all started with a faint glimmer in the vast canvas of the night sky, a discovery that seemed routine at first, but quickly unraveled into one of the most captivating cosmic enigmas of our time. Imagine this: astronomers scanning the heavens with cutting-edge telescopes, expecting perhaps another asteroid or distant comet, only to stumble upon something that defies the ordinary. On July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS telescope in Rio Hurtado, Chile, flagged an unusual object hurtling into our solar system at an astonishing 137,000 miles per hour. Designated as 3I/ATLAS, also known as C/2025N1 or A11PL3Z. This interstellar visitor was confirmed as the third of its kind ever detected, following the groundbreaking discoveries of 1I/Oumuamua in 2017 and 2I/Borisov in 2019. But as data poured in from observatories worldwide, what began as excitement morphed into bewilderment. This wasn't just another space rock passing through. It carried secrets that challenged our understanding of the universe. Stick with me through this journey, because by the end, you'll see why 3I/ATLAS isn't just a comet. It's a riddle wrapped in stardust, one that might redefine humanity's place in the cosmos. Let's set the stage properly to appreciate the sheer thrill of this event. Our solar system, that cozy bubble of planets, asteroids, and comets orbiting the sun, is occasionally graced by wanderers from beyond. Objects born around distant stars, flung into the interstellar void by gravitational chaos or stellar explosions. Oumuamua, the first, was a cigar-shaped oddity that zipped through without a tail, sparking debates about its shape and unexplained acceleration. Borisov followed, more comet-like with a visible coma and tail, but still alien in its chemistry. Now enter 3I/ATLAS, discovered amid a surge in astronomical vigilance, thanks to advanced surveys like ATLAS and the upcoming Vera C. Rubin Observatory. As of September 17th, 2025, this object is barreling toward its closest approach to the Sun on October 30th, making it a prime target for telescopes like Hubble, James Webb, and Gemini South. Its speed alone, 61 kilometers per second, sets it apart, nearly twice that of its predecessors, suggesting it was ejected from a particularly energetic stellar nursery. But speed is just the beginning. What truly hooks you is the anomaly that has astronomers buzzing, a plume of dust that appears to defy the laws of physics. Picture a typical comet. As it nears the sun, solar heat vaporizes its ices, creating a glowing coma and a tail that always points away from the sun, swept back by the solar wind and radiation pressure. It's a fundamental rule etched into every astronomy textbook. Yet early observations of 3I/ATLAS revealed something startling: a dense jet of material projecting sunward, toward the very star that's supposed to repel it. NASA-funded Hubble images from July 21st captured this teardrop-shaped cocoon of dust, and follow-up data from Gemini South confirmed a growing tail, but with peculiarities. Reports indicate dust shooting toward the sun, a phenomenon reminiscent of rare anti-tails seen in some comets when Earth views them edge-on to their orbital plane. But in 3I/ATLAS's case, the persistence and density of this sunward feature have raised eyebrows. Veteran comet expert Bryce Bolin, involved in the initial analysis, described it as blobby and sunward, unmatched in the archives. Is this an optical illusion, a data glitch, or something more profound? As we dive deeper, you'll see how this one detail spirals into a web of intrigue that keeps you glued to the screen. The orbital path of 3I/ATLAS only amplifies the mystery, painting a picture of a cosmic intruder on a precision-guided tour. With an eccentricity exceeding 6, far beyond the typical hyperbolic paths of interstellar objects, it's slicing through our system like a scalpel, unbound by the sun's gravity and destined to exit back into the void. Its retrograde motion, opposite to most solar system bodies, aligns eerily with Earth's orbital plane, within just 5 degrees of the ecliptic. By late July, data from the Large Binocular Telescope and the Very Large Telescope in Chile refined its trajectory. A close flyby of Mars on October 3, 2025, skimming within striking distance, followed by brushes near Venus in November and Jupiter in March 2026. The odds of such sequential planetary alignments for a random interstellar visitor? Astronomers calculate less than 1 in 20,000. It's as if 3I/ATLAS is threading a needle through our celestial neighborhood, using gravity assists in a manner eerily similar to how NASA designs spacecraft missions like Voyager or New Horizons. But here's the hook. Subtle deviations in its path suggest non-gravitational forces at play, tiny accelerations that nudge it sunward. Models incorporating a thrust-like push of about 4 times 10 to the -7th meters per second squared fit the data perfectly, reminiscent of ion engines on human probes. Could this be natural outgassing or something engineered? Hold on, because as we explore the chemistry, the plot thickens. Delving into the spectral heart of 3I/ATLAS via the James Webb Space Telescope, JWST unveils a composition that's outright alien. Solar system comets are water-dominated, with carbon dioxide as a minor player. But 3I/ATLAS flips the script. Its CO2 to water ratio hovers around 8 to 1, 4 standard deviations above the norm, with significant carbon monoxide thrown in. This suggests formation in a frigid, CO2-rich environment around a distant star, where water stayed locked in rocks while CO2 froze out. Adding to the puzzle, detections from the Very Large Telescope revealed atomic nickel in quantities rarely seen, without the usual accompanying iron vapor, a chemical fingerprint unseen in our local comets. No xenon, the hallmark of human ion drives, but the CO2 and nickel could theoretically be ionized for propulsion. JWST's spectrographs show monoenergetic particles in the plume, a narrow velocity range hinting at uniform acceleration, not the chaotic spread of natural sublimation. It's dense, collimated, and holds formation like a manufactured jet. Harvard's Avi Loeb, no stranger to bold ideas after championing Oumuamua as potential tech, posits this could be an alien probe decelerating via the Oberth effect, firing engines at perihelion for maximum efficiency. NASA counters that it's natural, with Tom Statler emphasizing it looks like a comet and does comet things, but admits intriguing differences. As theories clash, you're left wondering, is this nature's quirk or a sign of intent? Now imagine the tension building as 3I/ATLAS approaches its solar conjunction on October 30th, 2025, a blackout period when it slips behind the sun, invisible to Earth-based instruments for weeks. This is the ultimate cliffhanger in our cosmic drama. Pre-conjunction trajectory places it in a sequence of flybys that feel too precise for chance, and those non-gravitational residuals persist, aligning with the sunward plume. If this is thrust, conjunction is the perfect cover for a maneuver, altering course undetected until emergence. Planetary defense teams at NASA and ESA are on high alert, running simulations that factor in everything from dust dynamics to exotic volatiles. Yet nothing fully explains the consistency. The plume doesn't waver, the acceleration is steady, and the chemistry screams outsider. Whispers in scientific circles suggest this could be part of a larger pattern, linking back to Oumuamua's unexplained speedup and Borisov's odd organics. What if these aren't isolated events but a sequence? Oumuamua as shape test, Borisov as chemistry probe, 3I/ATLAS as propulsion puzzle. The idea of lurker probes, ancient alien tech hiding in plain sight, gains traction in SETI discussions, especially with Vera Rubin set to spot dozens more interstellar objects annually. But let's not jump to conclusions without exploring the counter-arguments, because science thrives on skepticism. A cadre of astrochemists argues 3I/ATLAS represents a new class of extreme interstellar naturalism, perhaps debris from a shattered exoplanet or supernova remnant. The sunward dust could be an anti-tail illusion caused by larger particles orbiting in the comet's plane, appearing to point forward when viewed from Earth. The high CO2 might stem from formation in a carbon-rich protoplanetary disk, and the nickel from metallic ices unique to its origin star. Simulations at the Minor Planet Center test thermal fracturing, rotational jets, and anisotropic mass loss, finding fits without invoking intelligence. Even the orbital alignments? Statistical flukes in a vast galaxy. NASA insists the evidence points overwhelmingly natural, with no threat to Earth. Its closest approach is a safe 1.8 astronomical units. Yet even skeptics admit the anomalies push boundaries, forcing us to rethink comet behavior. This balance of wonder and rigor is what makes astronomy so addictive. It's not about aliens invading, but about expanding our knowledge horizon. As September 17, 2025, marks a pivotal point in observations, 3I/ATLAS visible post-sunset through telescopes, its tail growing as it heats up, the global community rallies. Amateurs and pros alike train scopes on this fleeting guest, capturing data before the sun's glare swallows it. Reports from South America, Europe, and Australia note glitches in tracking. Signal dropouts, delays tied to specific frequencies. Is it electromagnetic interference from the object or mere coincidence? Some liken it to a probe scanning our tech, but experts attribute it to solar interference ramping up. Meanwhile, supercomputers churn millions of models, only aligning when introducing directed emission, abandoning randomness for pattern. This shift echoes orbital fingerprinting used in satellite tracking, revealing alignments with historical paths that hint at a cosmic highway. Overlaying these with Earth's milestones, space-age dawn, radio broadcasts, sparks speculation, timed visits, not random. Re-examining predecessors through 3I/ATLAS's lens revives old debates. Oumuamua's pancake shape and non-grav push now seem prescient. Borisov's CO dominance a precursor. Theories posit a galactic grid of observers, passive until detected. With Rubin Online, forecasts predict a deluge of discoveries, potentially exposing more anomalies. Early alerts flag another inbound object, steep-angled and tailless. Could it be 4I? Statistically improbable to have 4 in under a decade, unless we've just learned to see them. This wave could shatter models, announcing we're not alone in noticing. In hushed forums, engineered approach, murmurs grow. Eccentricity, velocity, flybys, plume, chemistry, all suggest intentionality. Perihelion timing with blackout? Strategic. If probes, they're silent scouts, testing reactions. We're the observed, our science the response. Not invasion, but a threshold cross, from assuming emptiness to questioning patterns. Yet the real magic lies in what 3I/ATLAS teaches about us. Telescopes built to gaze out now reflect back, shattering isolation illusions. It arrives masked in nature's tongue, dust, gas, orbits, but whispers a deeper grammar. Sunward tail resisting wind, acceleration defying gravity, alien chemistry, precision timing. Behind the sun's curtain, what transpires? Nothing? Everything? A test of attention. Not spacecraft story, but ours. Crossing into galactic awareness. 3I/ATLAS. Mirror, signal, question. And perhaps the answer awaited. To truly grasp this, let's backtrack to interstellar origins. Stars form in nebulas, planets coalesce from disks. Disruptions, close stellar encounters, supernovae, eject bodies at escape velocities. 3I/ATLAS, from Sagittarius direction, likely wandered eons, surviving radiation, collisions. Its speed implies violent birth, perhaps binary star slingshot. Hyperbolic path, incoming asymptote from infinity, perihelion whip, outbound forever. But alignments? Gravity assists could decelerate for capture, disguised in conjunction. Composition details, JWST spectra show CO2 dominance, implying CO2 ice mantle, water deeper, nickel, perhaps from organometallic compounds. No iron selective volatilization. Plume, if sunward, anti-tail of heavy grains. But persistence suggests thrust. Loeb's theory, alien sail or engine using Oberth for brake. NASA's stance, natural, with differences enriching understanding. No destruction intent, safe passage. Future, post-conjunction, re-emergence. December 2025, visible year. If path shifts, reevaluate. Rubin AI detectors, flood of data, rewriting dynamics. Implications for SETI, passive probes logical, efficient, low risk. If 3I/ATLAS1, others lurk. Oort cloud hideouts? We're advancing. JWST-ELT, probing exoplanets, biosignatures. Human angle, inspires wonder, unites. Backyard astronomers contribute, citizen science thrives. As conjunction nears, suspense peaks. Will it emerge unchanged or altered? Stay tuned. This cosmic tale unfolds, inviting you to witness history. Expanding on history, pre-Oumuamua, interstellar rare. Pan-stars found first. Borisov, amateur spot. 3I/ATLAS, ATLAS alert. Multi-telescope confirm. Anomalies detail. Hubble teardrop coma, unusual polarization, particle size/shape hint. Tail development. Gemini images show growing, gas dust. Composition matches solar comets, suggesting universal processes. Yet sunward dust, if real, challenges models. Possible Yarkovsky effect spin or magnetic fields. Theories evolve. Natural extremism versus tech. Either way, galaxy stranger. Another object? Preliminary, but timing terrifies. Wave incoming. We peered voidward, now void peers back. 3I/ATLAS shatters illusions, quietly masked. Buried grammar. Against windtail, resist gravity accel, belong not chemistry, scalpel precision. Maximum energy moment, vanishes untrackable. Curtain shadow silence. Tested with patterns, clues, friction. Paying attention. Threshold cross. Assume not empty. Ask why not look that way. Mirror, signal, question, answer wait.